Hi everyone, this is Shruti Pandey from the Chemical Engineering Department of IIT Kanpur, and I welcome you to the second lecture of the chapter Haloalkanes and Haloarenes in Chemistry of Class 12. So, in the previous lecture, we discussed about the requirements of aromaticity, which included the Huckel's rule, that is the number of pi electrons in that ring in that ring must be equal to 4n plus 2. Only then that cyclic compound or the cyclic hydrocarbon will be considered as aromatic. Then we also talked about the structure of the haloalkanes and the haloarenes and their applications in the medical field as well. Then we went through their classification on the basis of number of halogen atoms, then on the basis of the sp3 carbon and the halogen bond, and sp2 carbon halogen bond. In the last, we also mentioned about the nomenclature that included both the common names and the IUPAC names. Then we ended up doing several examples of the both common and the IUPAC names. So now today we are going to start mainly the methods of preparation of the haloalkanes and the haloarenes. But before that, I would like to discuss about the nature of the carbon-halogen bond. That is, what is this carbon, that the CX bond? What is it like? So the halogens, they are more electronegative than the carbon atom. Here electronegativity means that electronegativity is basically the tendency for an atom of a given chemical element to attract the shared electrons when forming a chemical bond. That means, in simple terms, if we talk about that, whenever any bond is formed between the two atoms, okay, so every element or every atom has a certain property, कितना ज़्यादा उसका capability है उस bond के electrons को अपनी तरफ खींचने का, ठीक है, तो वो कितना amount से वो उसको attract कर पा रहा है electrons को अपनी तरफ, ठीक है, तो वो उस atom और उस element का that is known as the electronegativity of that element. So what the thing is, कि halogens, they are more electronegative than carbon. That means they have more capability to attract the electrons which are which are taking part in that chemical bond. So the carbon halogen bond of the aryl halides, that is polarized. So polarized means जैसे like see, suppose this is the carbon and this is the halogen X. Okay, this bond, this bond includes some of the electrons that are taking part in the chemical bond. Okay, so these electrons, because the halogens, they are more electronegative, तो इस bond में जो भी electrons participate कर रहे हैं halogen उसको it has more tendency to attract the electrons towards itself. तो वो अपनी तरफ इन electrons को खींचेगा, it will attract, और carbon उतनी तेजी से नहीं attract कर पाएगा. So because of this, there is a charge separation that is there between the C and X. So this charge separation, it means that the carbon halogen bond is polarized. Okay. So let me write this. It is polarized. मतलब charge separation हो जाता है. तो जब when the electrons they are attracted by the halogen, तो halogen की तरफ partial negative charge आ जाता है halogen पे, and the carbon atom, because the electrons are getting away from the carbon. Okay, so you must be aware, no, कि when the electrons, when more electrons are there or when they are being attracted, so there is a negative charge, and when the electrons are going away, then the atom develops a positive charge. So same is the case over here also. कि यहाँ पे electrons, halogen के पास electrons आ रहे हैं, मतलब not आ रहे हैं, but they are attracted. So इस वजह से partial negative charge आता है. This is delta minus. This delta mean partial. Partial क्यों है? Because completely नहीं आ रहे हैं. ठीक है, हम like when we write ना कि Na plus लिखते हैं, like this is sodium plus ion, or this is Cl minus ion, the chlorine, the chloride ion. So this plus and minus, that is a complete charge. Complete मतलब क्योंकि क्लोरीन ने इलेक्ट्रॉन गेन किया है, दैट्स व्हाई हम वो नेगेटिव, कंप्लीट नेगेटिव चार्ज आ रहा है, एंड सोडियम हैज डोनेटेड अ इलेक्ट्रॉन. ठीक है, तो इस वजह से वो पॉजिटिव चार्ज आ रहा है, कंप्लीट पॉजिटिव. बट हियर वी आर टॉकिंग अबाउट द पार्शियल चार्जेस. पार्शियल मतलब पूरी तरीके से इलेक्ट्रॉन इज नॉट गेटिंग ट्रांसफर्ड कंप्लीटली, बट इट इज जस्ट बीइंग अट्रैक्टेड। ठीक है, तो इलेक्ट्रॉन क्लाउड जो है थोड़ा बहुत शिफ्ट हो सकता है इस अट्रैक्शन की वजह से। सो इस वजह से पार्शियल नेगेटिव चार्ज आता है, एंड हियर कार्बन विल सिमिलरली गेट द पार्शियल पॉजिटिव चार्ज। ठीक है, सो ये जो चार्ज सेपरेशन होता है बिकॉज ऑफ द इलेक्ट्रोनेगेटिविटी कॉन्सेप्ट, that is responsible for the polarization of the CX bond. Okay, so one important property of the CX bond we got to know that it is polarized, and then there is a development of the partial positive and the negative charges. Now the second thing that I want to talk about is the bond length. So in the periodic table you must have studied, or like you must be aware of this thing, that when the size of the halogen atom increases, like not halogen, any atom, it increases, the bond length also increases. So here it's halogen, so here we are talking about the CX bond. Carbon will the carbon size will the size of the carbon atom will remain same, but when we are talking about the different kind of halogens, when the size of the halogen atom increases, the bond length also increases. ठीक है, तो see, for explaining this, suppose this is the carbon atom and this is the halogen atom. ठीक है, and there is a bond between them, like they are forming a chemical bond. Chemical bond actually it involves the sharing or the transfer of electrons. So there is this presence of the electron clouds basically. ठीक है, तो now when suppose this is carbon and this is halogen, let's suppose this is the smallest halogen, which is the fluorine. Now we take about the carbon will remain same, but if we talk about chlorine, that is bigger than this fluorine, right? So suppose this is chlorine, this is carbon, this is chlorine. So chlorine is bigger than fluorine. You can check it from the periodic table that the size of this chlorine is more. So you can clearly see that as the radius of the halogen atom will increase, this जो distance है between the centers of both the molecules or both the atoms, ये भी बढ़ जाएगा, and that results in the increase of the bond length. So now if we talk about, like, if we want to write out the order for the bond length, we can say this CF bond is the bond length is the smallest. Then we have CCl. This is even smaller than CBr, and CI bond length is the largest. So this was the second property, that is the bond length of the carbon halogen bond. Now we would like to move to the second topic for today, and that is the method of preparation of haloalkanes. So see, there are many methods, there are many ways by which we can prepare the haloalkanes. So I would methods of preparation. Okay, so the first one is from the alcohols. Right, now from the alcohols also there are three ways that are mainly followed for preparing the haloalkanes. So in these three ways, they are when the alcohols they are reacted with either of the halogen acid or the phosphorus halide or the thionyl chloride. Okay, so these three ways are there in this from alcohols. It has three subcategories. Okay, so it would be easier for you to remember. There are three categories. So first is halogen acid. We can write it in the short form, like in the formula. It is HX. Then the second way is the phosphorus halide. So we can it can be like there are two kinds. No, it can either be the trihalide or it can either be the pentahalide. So this is phosphorus and this is pentahalide. X3 and XI. Okay. And then the third way is the thionyl chloride. It is SOCl2. The formula for thionyl chloride is SOCl2. Okay, so there are three ways. Now, out of these three, thionyl chloride method is preferred because it gives the pure alkyl halides. Why? Because abhi hum, like when we'll go through the reactions in detail, all these three reactions in detail, we will see ki the products which are formed in this reaction, in the last one, it includes the alkyl halide and it includes SO2 and HCl. And SO2 and HCl which are formed, they are in the gaseous form. Gases निकलते हैं, ठीक है. So as you can simply imagine कि अगर gases, if gaseous products are formed, then they will simply escape. ठीक है, वो उड़ जाएंगे, they will escape, and so we are only left with alkyl halide as a product. ठीक है, तो हम लोग like we prefer this category because these gases they can simply escape and we get the pure alkyl halide. बाकी दोनों cases में we'll see कि we have some other compounds जो कि escape नहीं होते हैं and फिर बाद में we need to separate these from the alkyl halide. Okay, so now we'll get into detail of these reactions. So for the first category, that is the halogen acid. So in this, in this the ways are different for the primary, secondary, and the tertiary alcohols. So for the primary, I'm just writing it down separately. So for the first category, that is A category, that is the HX1. We have, or just let me just write down primary. 1 degree is primary, and secondary alcohols, 2 degree alcohols. Okay. So again, like in the previous lecture also we discussed na ki 1 degree and 2 degree alcohols, meaning what? Like 1 degree alcohols is when the OH group is attached to some carbon and that carbon is itself a primary carbon. Okay, primary carbon matlab it is attached with the three species with a single bond. Okay, double bond does not exist there. So it is like when it is attached to one alkyl group, so it is primary. When that carbon is attached to the two alkyl groups, two other carbons, then it is secondary carbon. So similarly, यहाँ पे भी है same कि if the alcohol is attached to a carbon and that carbon is primary, then हम उस alcohol को बोलेंगे primary alcohol. ठीक है. So ये जो category है 1 degree and 2 degree alcohols के लिए, the reaction here is ROH, this is the alcohol, plus HCl, this is the halogen acid. The halogen acids are HX, that is HCl, HBr, HF, and HI. So the special thing in this case is that for the primary and the secondary alcohols, we need ZnCl2. I mean, the presence of ZnCl2 is a must for the reaction to happen. And so ये simple substitution है, यहाँ पे R and Cl बन जाएगा and this H and this OH group. This H, this OH group and this H, they come together and give water. ठीक है? So this was like this ZnCl2 thing is a thing that has to be remembered here. That is especially for the 1 and 2 degree alcohols. And if we talk about the tertiary alcohol, that is a 3 degree alcohol, we do not need the ZnCl2 and we can simply shake the alcohol with the concentrated HCl and the reaction will happen. So only shaking required. Okay. Now coming to the alkyl bromide. This was for the alkyl chloride. Now we'll come to alkyl bromide. So the alkyl bromide reaction, it gives ROH. We need the halogen acid and this halogen acid is 48%. This is 48%. And here constant boiling. And we will simply again substitution, we will get RBr and again water. Fine. So this was for the alkyl bromide. Then we come to the alkyl iodide. So here also something special is there. See, these reactions for the different halides, they are different. Then the way to manufacture them, the way to prepare them is different, because every halide, every halogen, it has a different properties, right? We'll study about the chemical properties, then we'll do it in detail. But the electronegative character, their size, and their density, their solubility, everything matters here, okay, for the reactions to happen. So only because of the difference in their chemical properties and their physical properties even, this difference, it leads to these different kind of reactions for the different halide. So this might be a little confusing. We can take sodium iodide over here, or we can even take potassium iodide, NaI or KOI. Okay. And here the reaction, it happens in the presence of 95% orthophosphoric acid. It is H3PO4. Okay. So this is orthophosphoric acid in the presence of an acid, which may be because you will also study like this iodine, this iodide ion, it can get the reaction to be reversible. So generally, whenever there is a reaction which is involving the iodide ion, we generally use the powerful oxidizing agents in the reaction, so that the reaction is not reversible, and the products are properly formed. So it acts as an oxidizing agent here, H3PO4, and this we will get Ri plus. Here we will get NaOH, or if we are using Ki, we will get KOH. Sodium hydroxide and potassium hydroxide. Okay. So this was for the first category, and talking about the order of reactivity of these alcohols that we just studied to 1 degree, 2 degree, and 3 degree. So the order of reactivity is 3 degree is the most reactive type of alcohol, and in 1 degree is the least reactive. Primary alcohols, they are least reactive. So this was all about the first category, that is the HX, that is the halogen acid category. Okay. Then we'll move on to the second category, that is the phosphorus halides, right? So let me write it down as B. This is the phosphorus halides category. So I'm writing down the reaction. The CROH, this is the alcohol. PX3 means the trihalide. Okay, phosphorus trihalide. It will give 3RX and H3PO3. And for this reaction, you must remember that X here. Again, I just now I told you that the different halogens, they have different properties. So all the reactions, they are not common for all of the halogens. Okay. So here for this reaction, you must remember that it is only applicable for either Cl or Br. This reaction will not happen in the case of iodine or fluorine. Okay, that is the phosphorus iodide or phosphorus fluoride will not allow this reaction to happen. Okay. So, okay, this is for the chlorides and the bromides. Then there is one other way for the chlorides. It is the reaction says it is ROH plus pentachloride, phosphorus pentachloride will give RCl plus POCl3 plus HCl. Okay. So in this reaction, it says in situ, and we will get Rx. Now, this reaction is also favorable only applicable for X, which is equals to bromine and iodide, and not for chlorine. Why? Because the phosphorus halides, which are like phosphorus bromides and the phosphorus iodides, I mean, they are not very stable compounds. So what we do here is, in this reaction, we prepare the phosphorus halides, मतलब these bromides and iodides, then and there, मतलब during the reaction ही हम उन्हें prepare कर लेते हैं. In situ का मतलब होता है, in situ means at that point only, at that point of time, at that location ही हम prepare करते हैं, पहले से लेके नहीं आते as a reactant. ठीक है, तो यहाँ पे हमारे पास alcohol है, and in that mixture only we will prepare. And how we will prepare that? We will react this red phosphorus and the bromine or the iodine. Okay, when we will react both these, the red phosphorus and the bromine and iodine, we will get the halide, the phosphorus halide we will get, and then that halide will react with the alcohol then and there, and it will get the alkyl halide. ठीक है, सो दिस जो इन सिटू प्रिपरेशन है ये बस ब्रोमीन और आयोडीन के लिए एप्लीकेबल है. ठीक है, बाकी दोनों के लिए नहीं है. So this was about the second category, that is the phosphorus halide. Now for the third category, that is the thionyl chloride, that is thionyl chloride is SOCl2. So plus this is the alcohol, this is the thionyl chloride, and it will give RCl plus SO2 plus HCl. Okay, and now I mean, it's obvious here that we are using SOCl2 only. Okay, so we will only get this method is for the chlorides only. I mean, not the other halides are involved here. Now, these methods that we have just studied, that is all these three categories, they do not apply to the aryl halides, as the carbon-oxygen bond, because in aryl halides what happens is that there is a phenyl ring, like there is a phenylbenzene ring there. So the carbon-oxygen bond in the aryl halides, it has a partial double bond character. Okay, so that because of the electronegativity difference, maybe because oxygen is very much is like more electronegative, highly electronegative than carbon. So because of this electronegativity difference, there is a partial double bond character. मतलब जो partial charges आते हैं वो भी बहुत ज़्यादा strong होते हैं, and that develops a partial double bond character. And as you know that double bonds, they are stronger than a single bond. So वो जो CO bond होता है, that CO bond is very much stronger, and these methods they do not apply to the aryl halide. Okay. Now coming to the second method of preparation. अभी तक what we did was, अभी तक हमने बस first method discuss किया, that is from the alcohols, and that alcohols like through the alcohol we were like we had three ways, A, B and C. Okay. And now we are going on to the second method of preparation of alkyl halides from alkenes. Second is from alkenes. Okay. So this method is called free radical halogenation, क्योंकि इसमें the UV light is involved, and like whenever the ultraviolet or the sunlight is involved, the free radical formation always takes place. So that is why because free radicals, they are formed in the mechanism, so that is why it is known as free radical halogenation. Okay, so let me write down the one reaction, and then I will discuss about the mechanism. So plus Cl2, or we can write it in this way, it is UV. See, this is propane. Okay, so there are two types of carbons which are present in this compound. Okay, yes, so there are two types of carbons which are present in this compound, because see this, the first carbon, it is attached to only one carbon, so it is primary. The second carbon, like let me write it down here, this is 1 degree carbon. Okay, this carbon which is attached to the two other carbons, it is 2 degree, and again this last carbon is again 1 degree. ठीक है, so दो टाइप के कार्बन है इस प्रोपेन में. ठीक है, so whenever this chlorine will get attached, like whenever halogenation will take place, so there are two places for that chlorine to get attached, chlorine radical. So what will happen is either it can get attached to this 1 degree carbon, or it can get attached to the second degree 2 degree carbon. So there are two types of products which are formed over here, as you can see. ठीक है, यहाँ पे 1 degree से attached है पहले वाले में, और दूसरे वाले में 2nd degree से attached है chlorine. But see, this is only a small molecule which is propane. If we take the larger molecule, or which is suppose we take a some complex alkane. I mean, it has some side chains which are involved, and different types of even 3 degree carbons are present there. Okay, different isomers are there. So some complex isomer is there with some side chains, and there we are doing the free radical halogenation. So what happens is it gives the जो भी product आता है, that is a complex mixture of the isomeric monohaloalkanes and polyhaloalkanes. ठीक है, अब इसी में some other chlorine free radical होगा, and it can also get attached to some other carbon. It can replace some other H and it can get attached to that carbon. ठीक है, तो इस वजह से polyhaloalkanes भी possible हैं. ठीक है, so now that means that we have a complex mixture जो कि which will contain the monohaloalkanes, that is the compounds with 1 chlorine, the compounds with 2 or 3 chlorines maybe, and even their isomers, and which degree carbon it is getting attached. So I mean, there is a very there's a mixture of so many compounds that we get in the product that this method is not preferred. Okay, because if we need one kind of alkyl halide only, if we need one kind of alkyl halide, then we need to separate that alkyl halide from the remaining other isomers. So which is again a very there's a problem. So they are not easily separable. So that is why this method is not preferred. Now the third category is from the alkenes. Okay. Now alkenes also involves two methods. Okay. In this also there are two methods. One is from the hydrogen halides, which is HX, and the second is the addition of the halogens, मतलब directly X2. तो ये HX भी ऐड करके बना सकते हैं alkenes में, और X2 भी बना सकते हैं. दोनों के जो methods हैं, दोनों के rules जो हैं, they are completely different. So we'll look it up, like we'll look them separately in detail. So the first category, which is the hydrogen halides. Okay, so here suppose one alkene is there. I'm only writing the double bond here because any other groups, they can be attached to these carbon, it doesn't matter. I mean, these four groups, they can be anything, and this double bond is there, and when it is reacting with the hydrogen halide, that is HX, what it will form is C. This, like, what happens is this first, like if we discuss about the mechanism, this HX bond will break, and it will like this HX bond will break, and it will give H plus and X minus. Okay, ions. So hydride ion and the halide ion. Now this H and X, both the ions, they will go to these carbon atoms which are a part of the double bond, and they will try to remove the unsaturation. मतलब डबल बॉन्ड को हटाने की कोशिश करेंगे ताकि सैचुरेट हो जाए, सैचुरेटेड कंपाउंड बन जाए. ठीक है, सो दिस H and this X will separately attach to both of these carbons, and so we will get something like this. जैसे ये C है, ये डबल बॉन्ड जो हो जाएगा ये सिंगल बॉन्ड हो जाए बन जाएगा बिकॉज अनसैचुरेशन हैज बीन रिमूव्ड, एंड एक कार्बन पे H लग जाएगा and the second carbon X will get attached. So we will get something like this. Okay. Now it was easy to understand this, but it is not as easy as it seems because I'll discuss one example, and then suppose we are taking propene. Okay. This is CH and this is double bond over here, and it is CH2. And यहाँ पे हमने कोई भी HX ऐड किया, and then so see जैसे अभी like from when we were discussing the free radical halogenation, that chlorine atom it has two choices कि वो 1 degree पे भी लग गया था जाके कार्बन और 2 degree कार्बन पे भी it was getting attached. ठीक है, so there were two options for the chlorine atom to get attached. Here also if you analyze this, because now what we have is, अब हमारे पास क्या है, after the breaking of the bond we have H plus and X minus, right? अब दो आयन्स है हमारे पास, अब हमारे पास दो कार्बन है, यहाँ पे भी दिस कार्बन भी है और ये वाला कार्बन भी है. तो अगेन H has the option to choose from which of the carbons, from either of these carbons, and X minus, the halide ion, also has the option to choose from either of these carbons. तो जो दो तरीके के प्रोडक्ट इस केस में बनेंगे, दे विल इंक्लूड HPC, जब हाइड्रोजन जो है वो बीच वाले कार्बन पे लगा और हैलोजन लास्ट वाले कार्बन पे, और the other product that can form here is जब हैलोजन बीच वाले कार्बन पे लगा और हाइड्रोजन लास्ट वाले कार्बन पे. ठीक है, तो ये दो प्रोडक्ट्स जो हैं वो इस केस में पॉसिबल हैं. Now it may seem, if I ask you that suppose suppose 1 mole of propene is being reacted with 1 mole of HX, then what will be the product, like what will be the quantity or the amount of these products which are getting formed? तो simply हम like ऊपर से देख के just ऐसे ही बोल सकते हैं कि हाँ 50% the first one and 50% the second one. That means 0.5 moles will get the first one and 0.5 moles of the second one. But this is actually not the case. From the experiments, what has been observed is that ये जो पहला वाला है प्रोडक्ट, इसका क्वांटिटी इसका अमाउंट बहुत कम होता है एज कंपेयर टू द सेकेंड वाला. सो द सेकेंड कंपाउंड is major here because उसका ज्यादा बनेगा. I mean 90% we are getting the second one and only the 10% the first one. And why is it so? Because जो उसके पीछे का मैकेनिज्म है that has been just told as a rule, that is known as the Markovnikov's rule. कि उसके पीछे के मैकेनिज्म को हम लोगों ने एक रूल के नाम पे बताया है. And that rule, let me like the name is a little bit awkward. Markovnikov's rule. So this rule, it helps us to understand that to which carbon the hydrogen will get attached and to which carbon the halogen will get attached. So what this rule says is, we will discuss it in detail, that whenever a protic acid is added to an asymmetric alkene, ठीक है, तो protic acid is this HX and asymmetric alkene मतलब symmetric नहीं है ना. Symmetric मतलब there is no symmetry. अगर symmetry होती है तो फिर choice ही नहीं होती, वो कहीं पे भी जाके लगता है. So अगर if the compound is symmetric, so कहीं पे भी H और X लग जाएगा, that will not make any difference. Asymmetric alkene है अगर, which in this case is propene, the acidic hydrogen attaches itself to the carbon having a more number of hydrogen atoms, whereas the halide group attaches itself to the carbon atom with more alkyl substituents. ठीक है, so in simple terms if I explain you this, So the hydrogen, this rule says कि जो भी this rule says that the hydrogen, जो हाइड्रोजन है वो कहाँ पे लगेगा? It attaches itself to the carbon having more number of hydrogen atoms. तो ये कार्बन with more number of hydrogen atoms, and जो हमारा halide group है, it will get attached to the carbon with more alkyl groups. ठीक है? So this is the statement of the Markovnikov's rule, which justifies the presence of this second component as the major component in the product. ठीक है? तो अब देखो, अब अगर हम ये रूल इस पे अप्लाई करें हमारे ये प्रोटीन पे, दिस रिएक्शन, सो व्हाट वी आर सीइंग कि H जो होगा ना, दैट विल प्रेफर टू गेट अटैच्ड टू द कार्बन विद द मोर नंबर ऑफ हाइड्रोजन एटम्स. तो यहाँ पे देखो प्रोटीन में मान लो ये जो हमारा हमने इसको नंबर किया 1 कार्बन एटम, जस्ट टू एक्सप्लेन यू ऑल, दिस इज 2 कार्बन एटम. ठीक है? तो फर्स्ट नंबर 1 कार्बन पे 2 हाइड्रोजन लगे हैं और नंबर 2 कार्बन पे सिर्फ 1 हाइड्रोजन लगा हुआ है. ठीक है? तो अकॉर्डिंग टू दिस रूल, कार्बन विद मोर नंबर ऑफ हाइड्रोजन एटम्स इज द फर्स्ट कार्बन. ठीक है? एंड द H will get attached to the first carbon. So in the major product, if we see, the H is getting attached to this first carbon, and the halogen will get attached to the carbon with a more number of alkyl groups. यहाँ पे हमारे पास alkyl groups नहीं है, but again we can replace it and say that we can simply say, in other words, that C with less hydrogen. ठीक है? So the halide atom will get attached to the carbon which has less number of hydrogen atom, जो कि ये major वाले पे we can simply see कि ऐसा ही हुआ है. So this is an important rule, and this is not the only example where this rule applies. I mean, whenever you see an alkene and an HX kind of thing, the reaction between an alkene and acid, halogen acid, then I mean you'll have to apply this rule, क्योंकि there will, because the more number of products are being formed, and which product will be more in amount will be justified by this rule. Okay? So this was about the addition of we were discussing the preparation from the alkenes, and this was the first part of it, that is the addition of the hydrogen halide. Now coming to the second part of this alkene, from the alkenes, preparation from alkenes, the second part says the addition of halogens. So the part B was addition of halogens. So again we will take some alkene. We are talking only about these 4 groups, they can be anything, and we are adding bromine in CCl4, that is carbon tetrachloride. So we will get again this ये जो double bond है ना, again the unsaturation has to be removed. So फिर से it will get these 2 groups. In this case, there is we cannot apply Markovnikov's rule, because we know that here only those bromine ions, they do not have any, because these species are same. No, this bromine, it will when it will split, it will give the 2 bromide ions, right? So the bromide ions, they are same. So I mean wherever they attach, it will not make any difference. There the species, they were different. That is hydrogen and the halide ion. That's right. So we will get a structure like this, and this structure is called Wick dibromide. Wick here means that the bromine that are attached, that dibromide means there are 2 bromine atoms, and those 2 bromine atoms, they are attached to the carbon atoms which are adjacent to each other. Wick. That is why we are writing Wick. Now, what happens in this reaction is that we are taking bromine, that the bromine is a gas, no? So what we will do is we will dissolve this bromine gas in CCl4. So CCl4 is a liquid and bromine is a gas. We will dissolve this gas in this liquid and we will get a solution. Okay. And we will react this alkene in that solution. And we will get this compound. Now, the importance of this reaction. The importance of this reaction is that this is a very famous laboratory test that is used for the detection of the double bonds in the organic compounds. I mean, that laboratory test, if you we did certain laboratory tests, no, in 11th and 12th, you must have also done in your laboratories, school laboratories. So what we do is, it is when we dissolve this bromine in CCl4, we get a solution which is reddish brown. So what we do is bromine dissolved in CCl4. तो ये जो solution बनता है ना, this is reddish brown in color. ठीक है. And when it is reacted with the alkene, जो हमारा product है that is weak dibromide, इसका जो color होता है that is colorless. I mean this compound, this product is colorless. So when the reaction happens, we this reddish brown color is discharged. Discharge means this reddish brown color, it disappears and we get a colorless compound, colorless product. ठीक है. So that is used as a laboratory test. मतलब कि if that compound is containing a double bond, then the reddish brown color will disappear and the product will be colorless. That means it is a test for the detection of a double bond in any organic compound. Okay. So this was the preparation of haloalkanes from alkenes. Now we get to the another method, which is the halogen exchange method. The fourth method is okay. In this also there are two categories. So one is the Finkelstein reaction and another one is the Schwarz reaction. So in this category also we will first study what? Finkelstein reaction. And this reaction is only applicable for alkyl iodide. I mean, it's only for the preparation of alkyl iodide. It cannot form any other halide. Okay? It cannot form chloride, bromide, or fluoride. So this is a special reaction, and you need to remember the names because they can ask directly about the reaction from their name only. So this reaction, it only is only responsible for the preparation of alkyl iodide, and it says Rx plus sodium iodide will give Ri, that is the alkyl iodide, plus NaX. And we need to remember here that ये जो X है here, that is either Cl or Br. बाकी ये fluorine नहीं हो सकता because there is a different method for the preparation of fluorine that we'll just study in a few minutes. So this is here, this halogen, this X has to be either chlorine or bromine. So what happens is here this NaX. So whenever we are taking Cl or Br, we will get NaCl or NaBr. So this these are the precipitates. No, so these are formed as a precipitate in the reaction, and they favor the forward reaction according to the Le-Chatelier's principle. So Le-Chatelier's principle, it says that like after the equilibrium is reached, Le-Chatelier's is only applicable when the equilibrium has already reached. ठीक है, अगर equilibrium नहीं है and फिर हम कोई चीज कम या ज्यादा कर रहे हैं, then it will not be applicable. ठीक है, so after the equilibrium, after the reaction has reached with equilibrium point, if we are decreasing, like if we are increasing the product in the mixture, then the reaction will go to the, it will go in the backward direction. ठीक है, to decrease the product. And if we are decreasing the product in the reaction mixture, then it will go in the forward direction. ठीक है, तो आप ऐसे समझ सकते हो कि मतलब when the reaction has reached at the equilibrium point, then it will always want कि जो reaction है वो equilibrium पे ही रहे, हमेशा equilibrium पे रहे. अगर हम उसके बाद भी अगर हमने प्रोडक्ट को बढ़ा दिया, तो रिएक्शन ये चाहेगा कि प्रोडक्ट कम हो जाए ताकि फिर से इक्विलिब्रियम अचीव हो जाए. तो प्रोडक्ट को कम करने के लिए वो क्या करेगा, इट विल गो इन द बैकवर्ड डायरेक्शन. तभी तो प्रोडक्ट यूटिलाइज करेगा और वो रिएक्टेंट बना देगा. ठीक है, एंड सिमिलरली अगर हम रिएक्टेंट के बारे में बात करें, तो ली-चैटेलियर्स के प्रिंसिपल, अकॉर्डिंग टू द ली-चैटेलियर्स प्रिंसिपल, इफ वी आर इंक्रीजिंग द रिएक्टेंट, तो रिएक्शन चाहेगा कि रिएक्टेंट कम हो जाए, तभी वापस से इक्विलिब्रियम आएगा. तो रिएक्टेंट को कम होने के लिए क्या होगा कि द रिएक्शन हैज टू गो इन द फॉरवर्ड डायरेक्शन. ठीक है, तो दिस रिएक्शन है बेसिकली, आई मीन इट गिव्स द गुड यील्ड्स ऑफ दिस एल्काइल आयोडाइड की अच्छी खासी यील्ड मिल जाती है हमें, बिकॉज ये जो NaX बनता है ना, दिस इज इन द प्रेसिपिटेट फॉर्म. PPT बनता है इसका, प्रेसिपिटेट बनेगा तो इसका मतलब है कि वो एज अ सॉलिड नहीं, it will get collected as a solid, and the reaction mixture में the concentration of this NaX will decrease, and so the reaction will go in the forward direction, right? Now we will go to the second category of this halogen exchange, and that is also a special reaction, and that is the Schwartz reaction. And this reaction is for the preparation of alkyl fluorides only, no other halide. Alkyl fluorides only. ठीक है, so this is also a simple reaction. We take the bromide, we get RF plus AgBr. Okay, it is a simple double substitution reaction, but I mean this AgF, this is a metallic fluoride. So I told you just a few minutes back in this lecture itself that this iodine thing, it requires the oxidizing agents. It requires the oxidizing agents to be present in the reaction. ठीक है. Similarly, in the case of this fluoride, we will require the presence of the metallic fluoride. तभी हमारा alkyl fluoride बनेगा. So here हमने AgF use किया, that is silver fluoride use किया है. There are other substitutes also that you can use here. So I am writing because it is important. The presence of metallic fluoride, like what all things that we can use in the place of AgF. It is AgF, Hg2F2, cobalt fluoride, CuF2. Okay, so these are the metallic fluorides that we can use here. So next is the topic, like it is for the preparation of haloarenes. This was all for the haloalkanes. Abhi, all these processes, they are not applicable for haloarenes. There are different methods which are involved. So we will go to those methods in the next chapter, and in the next lecture. and there we will also discuss about the physical and the chemical properties of the haloalkanes and haloarenes, like physical properties like melting and the boiling points, their density, their solubility, how these properties they affect the reactions that are taking place. Okay, so this was all for today. Thank you.